Hey guys, welcome to our training session on understanding concrete exposure classes and mix requirements. So today we're going to go over concrete exposure classes and how they relate to what we're actually seeing in the field. The goal here today is simple. Before you ever run a test, you should already have an idea if the mix is right or wrong for the item that is to be poured. So over on my screen here, this is taken out of our plan set for one of our actual projects. In the structural details, I'm sure we've all kind of seen these. Up here, it says the minimum compressive strength of concrete at 28 days shall be 4,500 psi, blah, blah, blah. And then you look over here, and we got a bunch of numbers. Now, today, we're going to go over what those numbers mean and what they are. So on this particular project, the footings would need to meet this exposure class, your foundation walls for this class, interior slabs on grade, so on and so forth. So what these numbers are is F is going to be your freeze thaw, the S is going to be sulfates, W or P, could be either one, is going to be your water / permeability, and your C is going to be corrosion. Now, what those determine in the mix is going to be things like your required PSI, air content, water cement ratio, overall durability of the entire mix. So section 2 in our freeze thaw, you're going to come up here. So right here in this category for F, F0 is going to be concrete not exposed to freezing and thawing cycles. So what that means is you're not going to have any air in it. In your F1, it's going to be moderate, so it's going to be kind of your low air mixes. Generally on anything we see, especially for city right-of-way, sidewalks, curb and gutters, are going to be your F2, F3. Concrete exposed to freeze and thawing cycles and in continuous contact with moisture. Concrete exposed to freeze and thawing in continuous contact with moisture and exposed to de-icing chemicals. We don't live in Salt Lake area, so we don't use as many de-icing chemicals, but it still is going to classify as F2, F3. So if you come back down here, when you look at this, so the first part of that is F1, footings, foundation walls, interior slabs on grade, is going to be F1, moderate. So no air to little air mixes. Now, if you go back into that on your F3 exterior flatwork, sidewalks, drive approaches, things like that, it's going to be F3. Means it's going to be very severe according to this, and it's going to have air in it. So F0, just to recap, F0 is going to be a no air mix. F1, F2, and F3 are about 6% air plus or minus on the tolerance is where those come from when we get our approved mix designs and we look at those. The next section of this is going to be your sulfates. So pretty generally down here on everything we use is going to be your high sulfate mixes. It's going to be the HS, which is right here. So HS plus pozzolan, so your fly ash, stuff like that. Just down here, that's what we use. We don't test any of this in the field, but it's good to know what it means. This actually comes from the cement type, which is going to be the ASTM C595. All of our concrete mixes that we currently see are going to be classified in this C595. That's what they use. The next section on this is going to be your water and permeability, which is going to be your P mix here. So if we come up here, right there, requiring low permeability. In contact with water where low permeability is not required. In contact with water where low permeability is required. What that is your water to cement ratio and strength is what that's going to dictate. So your max on everything, if you come back up into this table here, if you look in that section here, no permeability is going to be 2,500. And then your low permeability, which is normally what we have, your water to cement ratio has a max of 0.5 and a minimum break of 4,000. This is why some mixes are tighter and stronger and other not as much. So come back down to our graph here. The next section is going to be the C, the corrosion protection of reinforcement. So what this is, this one can change everything. Example, plans say 4,000 psi, but C2 requires it to be a 5,000 psi break. Here's the reality. Plans often override, but technically exposure class should govern, but the plans and the specs are what actually govern what we do. But again, corrosion is concrete dry or protected from moisture, concrete exposed to moisture but not to external sources of chlorides, and concrete exposed to moisture and external source of chlorides from de-icing chemicals, salt, brackish water, seawater, or spray from these sources. That's going to be your curb and gutter and things of that nature. So if you come back up here, this is going to kind of what dictates our break schedule here. C2, 5,000, 2,500 for those. Now, in our next section, we're going to go over plans versus specs. So plans is what we usually have in the field. The specs are the actual true requirements of the job and what we're going for. So this is another job up here. Again, back to the structural details. This is the elements that they're planning to have poured. This is now what exposure category that they're requiring the concrete to be poured needs to adhere to. And this is also going to tell you what your strength is at 35 or at 28 days for your PSI. So your interior slabs on grade for this particular project would be 4,000, interior slabs on metal deck 3,000, 4,500, 4,000, 4,500, so on and so forth. So if you were to look at these codes, F0s, we know we're not going to have any air in them. Your F2s and F3s, we know we're going to have air. And then your S1 is going to be back to your sulfates. And then that W there is going to be your water permeability. So that's, again, where that's going to be exposed at. And then your corrosion, you know, where's it at? What chemicals are going to touch this? Things like that that are going to dictate. So what we're looking at is sometimes your plans may say 4,500 PSI. And the spec requires things like fly ash or shrinkage limits to be done on this as well, which would be in the mix design process. That doesn't have anything to do with us. So always kind of remember when we're out in the field testing, we're not seeing the full picture of what the mix design is doing on the back end and why it was designed the way that it was. So the mix design being simplified, we don't create a new mix for everything. If you notice, Suncor, Western Rock, when you're testing, have a lot of the same mix codes, and you see them on plenty of different jobs. When they go and they bid on these projects, they go through this set of plans and they have their mixes that they know meets those requirements. And then once they do that, they go in and they submit their mix designs that are going to meet the requirements that the plans are specifying here. So you'll have the same PSI, same exposure requirements, things like that. So multiple 4,500 mixes could very well be used for different things in here because it meets the same specs here. But the project spec itself varies from project to project, not necessarily what the mix design that Suncor has, because each job has its own set of requirements. Especially for slump. There's nothing in any of this that dictates what the slump is going to be. That definitely varies project to project, but at least when you're looking at stuff, you kind of have an idea why it's designed the way it is and what it's being used for and why it's being used in that application. But we still need to be making sure we're using the specs out of the plans here and checking for those things off the approved mix designs and whatnot to make sure that we're getting the right stuff. But when you show up to a job and say you're doing an interior slab on grade and something, and you know from this interior slabs on grade, I'm not supposed to have air, but they're sending you an air mix, that should be your first red flag of, hey, something's not right here. It's giving us an idea of what kind of mix we should be seeing. Now, when you go to slump, that is project specific, and we should always verify with the engineer, project inspector, or the submitted and approved mix designs that are for that project. Now, when you go into admixtures, super plasticizer, if they have what they call a half dose, usually they try to run about a 6-inch on the slump. A full dose would raise it to a 7-inch on the slump, but you don't want to push it past an 8-inch on the slump. When there's plasticizer, they are allowed to go wetter than what the approved mix design or the plans call for, because that is not adding to the water to cement ratio. Plasticizer actually acts as water in the mix, allowing it to be quote unquote wetter, but you still don't want to push past an 8 when you do that. Now, when we're in the field, once you get all this information, you've kind of looked at plans, we have an idea what we're looking at least what kind of mixes we should expect to see. Now, when we get the item to be poured, we should be asking ourselves, should this mix have air in it? Does the PSI make sense for the application? Does it match the placement type, which would be found here? And do I know what my specs for the project are? And if we don't have anything in our OneDrive that is the approved mix designs, the contractor or the general or the super on site is going to have those, because they would have had to submit those before they poured. Now, that's not going to be for city right away. That's going to be for project specific, but somebody's going to be able to have those. And we need to know what those specs are, because we have to make sure that the concrete we're testing adheres to what these specs are. This is a guideline, but the spec is the spec. So remember, a big part of our job is visual and observational. Especially with concrete, the biggest thing is what we're seeing and what we can gather from the plans and stuff like that. And it's, testing confirms what we already suspect. We can't, the word I'm looking for, we can't just guess. So in closing on this, if we understand what these exposure classes are and kind of what they mean and why they're designed the way that they are, we're not just testing concrete, we're actually starting to understand concrete and why it's designed the way it is. And that's what separates us as technicians from somebody just running numbers with an air pot and a slump cone. Anybody can get certified to do that, but not everybody understands concrete and why it is what it is and why it's used for the areas that it's used and what dictates that. So, yeah, thanks for attending the training on this today, and